Hello. Welcome back to my channel. Make sure that you like the channel, uh, you also subscribe, and you invite your friends. Okay, so today we have an interesting question, or rather, the topic. This comma E. The question reads: sketch the graph of the function g of x, which is equal to the negative of the root of 1 minus 2x. Hence, find the solution of the inequality. But as we're not much interested in solving the inequality, but for today we'll be much focused on how to plot the graph of radical function. This radical function. Okay, beautiful. So graphing a radical function. So we have a general graph on how to graph what radical functions. So we have something to say: y is equal to the root of x. So this is the general radical function. So for you to graph this, we all know that the general graph under the transformation rules is that the root of x comes out like this. This is the root of what? The root of x, like that. Okay, so if you want to see how it's coming out, you can make a table of values. You plug in for example, you get x to be 1, 2, 3, 4, 5, and other negatives, and you plug in and you find the values of y. Okay, but negatives won't give you or assist the solutions, because the negative will be giving you the complex numbers. That's why it's not even going this side, it's going this side. Okay, now we see the behavior of the graph. So this is the first one. The second one, if you have something to say y is equal to the root of negative x, the graph to shift from positives to negatives, so it will go this side. Y is equal to the root of negative x. Okay, then we have this question 3. So we say y is equal to negative, then the root of x. And let's put even this one, say y. So this is 4. Y is equal to negative, then negative root of x, like that. Okay, so this one, for us to plot this one, first we'll plot the original graph, then the general graph. If you plot the general graph, the next we'll plot now the effect of negative. Okay, the effect of what? The effect of negative. So for us to plot this graph, first we'll plot y is equal to the root of x, then y is equal to negative the root of x, like that. So if it's not the final graph, just to differentiate with the final one, just make it dotted. All right, so for us to plot y is equal to the root of x, we know that the general graph comes out like this. Easy. Then the effect of this negative, if a negative is outside, instead of it turning this side, it will turn down like this. Then this will be y is equal to negative f of what? Y is equal to minus the root of x. This. Then for this one, since the space is done, I'll just draw a simple one, a small one, but just make sure that you follow keenly. Okay. So for this one, we'll plot y is equal to the root of x. Y is equal to the root of negative x. Then y is equal to negative the root of negative x. So y is equal to the root of x. We know that the graph will come out like this. Then y, the root of negative x, the graph will flip to this side, Then the effect of this negative, which is outside, the graph, this one, will flip now to, will flip down or will flip to the opposite side. Like this. So this is y is equal to minus negative x, like this. This is a graph. Okay. All right. And the other thing is, if you have a number in front, let's say y is equal to 2, then the root of x, like this, or y is equal to the root of 2x, the graph will just be thicker. It will just grow big because it has been multiplied twice than the original. So if the original was like this, or the general came out like this, this is y is equal to the root of x, then y is equal to 2x. The graph will just be thick, or will just grow 2 times the general graph. So it will be y is equal to the root of 2x, like that. And if a number is below 0, or not below 0, but below 0.9, below 0.9 or below 1, the graph will just get smaller or thinner. So it will just get smaller or what? Or thinner. So instead of you having the general to be like this, then if it was y is equal to 0.9, then the root of x, or y is equal to the root of 0.9x. So this graph will just get smaller. It's a sketch, and it's not exactly to scale. They just want to see if you know how to play with what? With graphs. Okay, so this one will get smaller. So just slightly there, the examiner will see to say, okay, this graph had gotten what? Smaller. 0.9x, like that. Okay. Now from there, we see now the behavior. If you have something to say, y is equal to the root of x plus 1, and y is equal to the root of x minus 1. All right. So for you to plot this graph, first you have to plot y is equal to the root of x. Then you plot y is equal to the root of x plus 1. Even here, for you to plot this, you have to say y is equal to the root of x. Then you plot also y is equal to the root of x plus minus 1, like that. Okay. So for you to plot y is equal to x, the root of x, simple, it's easy. There. Then there it's 0. Then we know that the general graph of y is equal to the root of x comes out like this. Okay, comes out like this. So which is y is equal to the root of x. Then for you to plot this one, just know that under the transformation rules, if you have a positive or plus, the number, the graph will move the number of this, the number of steps will determine by this number. Then if it's a positive, the graph will move to the negative. If in this case, if it's a negative, the graph will move one step to the positive. So this one, since it's a positive, negatives are this side, the graph will move one step to the negative. So it will come out like this. To move one step like this, x plus 1. So if you had the 3 here, the graph would have moved from the initial origin 3 steps, 1, 2, 3. Sorry, 1, 2, 3 here. If you had the 3 there, if you had the 4, the graph will move 4 steps to the what? To the negative. So just know that if you have a positive here, the graph will move to the negative. If you have a negative here, the graph will move to the positive. It's just the opposite of the sign, which is what? Which is in between. Okay, same applies to this one. If I plot this one, you can't fail to do this one. All right, now we jot into what? A question, an examination what? Question. Okay, so we are told to sketch this one. So you can pause the video, you copy the question. Once you copy the question, then we solve together. All right. So the question is demanding us to do what? To sketch G. Okay. So the question is demanding us to what? To sketch f of x, which is equal to what? Minus the root of 1 minus 2x, like that. Okay. Beautiful. Great. Sure. Okay. So for us to sketch this graph, this graph, we say f or g of x is the same, is equal to minus the root of, so we arrange these ones, the ones inside. So it will be minus 2x, then plus 1. Right. Then so g of x will be equal to minus the root. So we factor out the negative. We factor out the what? The negative. So it will be minus, then 2x, then minus 1. Right. So when plotting, we'll plot first we'll plot g of x, which is equal to the root of x. Then also plot g of x, which will be the root of 2x. Then we'll plot g of x, which is equal to the root of 2x minus 1. Then g of x, which will be equal to the root of minus 2x minus 1, like that. Then the g of x, which is equal to minus the root of negative minus 2x minus 1, like that. So I have to plot 1, 2, 3, 4, 5 to arrive at what? At the final graph. All right. So then we do this. Okay. Just come a simple sketch. And always remember that when you're graphing, use a what? A pen. Right. So the first graph which you are graphing is just a general graph. All right. It's a general graph. So that we know that the general graph comes out like this. So this is y is equal to the root of x, like that. If this is a general graph, then we have plotted this one, we go to this one. So we have to plot g of x is equal to the root of 2x. So in the beginning of the video, I said if you have a number which is greater than 1, the graph will keep on what? Will keep on getting thicker. So this graph is more like it has been increased what? Twice. So just to show that, we would present by showing to say the graph has what? Has increased twice like this, 2x like that. Okay. Then the effect of -1. So this graph will move to the what? To the what? To the positive. How many steps? 1 step. Okay. So let's assume that here there is what? There is 1. There is 1. So we'll move according to the number which is here. So it is, since there is 1, we'll move 1 step. All right. So move one step like that. So this is y is equal to the root of 2x minus 1 like that. All right. Then the effect of this negative will turn this graph more like a mirror to the other side. So the graph now will shift to the other side. Okay. Then the effect of this negative, which is outside, to flip the graph. Instead of to this side or going back to this side, it will flip it more like a mirror, now downwards, right? So to come out like this. So this is y is equal to negative 2x minus 1 like this. Then you are what? You're home and dry. So make sure that whenever you're solving, you show your lecturer these steps to say, okay, I started with this, then this, then this, then this, and all these helped me to graph the what? The final. So that the person who's marking will say, okay, this is what this guy was trying to put across until he found and what? Graph the final graph. All right. Make sure you subscribe, you share, and you like. Right.